So let's just imagine that it's just a few years from now, and you've worked really hard and graduated from college, and you've gotten a degree in chemistry, and you've been hired to do a really important job by a pharmaceutical company. The job they're going to ask you to do is to verify that the active ingredient that they have in a medication is the actual formula that they're looking for. And this, is a real life example of how and why it's really important to study hard and really learn what you're doing because before you know it, you might find yourself in a position and, lives basically depend on your ability to do your job right. So this is again why it's important not to just simply try to memorize your way through school, but really think about some of the things that you're learning and how they might really apply in real life situations. Because you never know, you might end up being someone that people are going to rely on. So let's look at an example of how this all might play out. We're going to use an example of ibuprofen. Ibuprofen, you might know, is a pain reliever and is used to help relieve headaches and things like that. Let's suppose that you know that the ibuprofen contains 75.69% carbon, 8.8% hydrogen, and 15.51% oxygen. You also know from another experiment that the molar mass of this compound is 206 grams per mole. Okay, so this is a lot like problems that we've done in the past, except we're given another piece of information here that we didn't have in previous problems. The piece of information that we have here is the actual molar mass of this compound. We didn't have that in previous problems. We had to make an assumption that we had 100 grams or something like that. So rather than do that, we're going to work right off of that number, the 206 grams per mole. If we multiply the 206 times the percentage of carbon in that compound, then this will actually tell us the amount of carbon in grams that's in the compound. We can also do the same and calculate the grams of hydrogen, and we can also calculate the grams of oxygen. And again, this is the amount of oxygen, carbon, and hydrogen that are in the 206 grams. And so in this case, we find that 155.92 grams are carbon, 18.128 grams are hydrogen, and 31.95 grams are oxygen. As usual, if we divide these by the molar masses of these substances, we can calculate the number of moles of each of these elements. And that gives us 13 moles of carbon, 18 moles of hydrogen, and 2 moles of oxygen. That tells you then that the formula for this compound is C13H18O2, and that's the molecular formula of that compound. And so it's not too bad to do. It's pretty much similar to problems like we've done in the past, and if you practice those and think about what you're doing, they're not too bad. So good luck. Hope that helps.